Our solar system is a place of incredible wonder, filled with celestial objects that defy our imagination. From the smallest asteroid to the largest planet, each body holds its own mysteries and marvels. The vastness of space is a constant reminder of how much there is yet to discover. Among these celestial wonders, one planet stands out not just for its size, but for its sheer presence in the night sky. Among them, Jupiter stands out as a true giant, a behemoth that dwarfs all other planets combined. Its mass is more than twice that of all the other planets in the solar system put together. This colossal planet has been a subject of fascination for astronomers and space enthusiasts alike for centuries. Jupiter's sheer scale is difficult to comprehend, a testament to the vastness of the cosmos. Imagine a planet so large that over 1,300 Earths could fit inside it. Its diameter is about 11 times that of Earth, making it a true giant in every sense of the word. This immense size is not just a statistic, it has profound implications for the planet's gravitational pull and its role in the solar system. Imagine gazing up at the night sky and seeing a bright, shining orb. This is not just any star, but Jupiter, the largest planet in our solar system. Its brightness is due to its massive size and its reflective cloud tops, which make it one of the most visible objects in the night sky. That's Jupiter, the largest planet in our solar system. Its presence is so commanding that it has been observed by ancient civilizations for millennia. The Romans named it after their king of the gods, a fitting title for such a majestic planet. Even with the naked eye, Jupiter's brilliance is unmistakable, a beacon of light that has guided and inspired humanity for generations. It's so large that it's visible to the naked eye, a beacon of light in the celestial tapestry. This visibility has made it a key object of study for astronomers. With the advent of telescopes, we have been able to observe its many moons, its swirling clouds, and its iconic Great Red Spot. Each observation brings us closer to understanding this giant of the solar system. But what would it be like to stand on this massive planet, to witness its grandeur firsthand? Unfortunately, Jupiter is a gas giant, meaning it doesn't have a solid surface like Earth. Instead, it is composed mostly of hydrogen and helium, with no definite boundary between its atmosphere and its interior. Standing on Jupiter would be an impossible feat, but imagining it allows us to appreciate the planet's unique characteristics. Jupiter is a gas giant, a swirling mass of hydrogen and helium held together by gravity. Its atmosphere is a turbulent mix of clouds and storms, with winds reaching speeds of up to 400 miles per hour. The most famous of these storms is the Great Red Spot, a gigantic storm that has been raging for at least 400 years. It's a planet of extremes, with storms that rage for centuries and a magnetic field that stretches far into space. Jupiter's magnetic field is the strongest of any planet in the solar system, 20,000 times stronger than Earth's. This magnetic field traps particles and creates intense radiation belts, making the space around Jupiter a hazardous environment. In this exploration, we'll delve into the mind-boggling reality of Jupiter's size and uncover the secrets that lie beneath its turbulent atmosphere. From its powerful storms to its complex magnetic field, Jupiter is a planet that continues to captivate and challenge our understanding of the cosmos. Join us as we journey to this cosmic giant and explore the wonders it holds. To truly grasp Jupiter's immensity, we need a point of reference, something familiar to our human experience. Our minds often struggle to comprehend the sheer scale of celestial bodies, so we turn to comparisons that make these vast distances and sizes more relatable. And what better comparison than our own planet, Earth? Earth is the only home we've ever known, and its size and features are deeply ingrained in our understanding of the world. The Earth, our home, seems vast and expansive, with its towering mountains, sprawling oceans, and diverse landscapes. From the highest peaks of the Himalayas to the deepest trenches of the oceans, Earth offers a variety of terrains and environments that seem almost endless. But when placed next to Jupiter, it becomes strikingly clear just how small we truly are. Jupiter, the giant of our solar system, dwarfs Earth in every conceivable way. If Earth were the size of a nickel, Jupiter would be about as big as a basketball. This simple analogy helps us visualize the enormous difference in size between the two planets. That's a significant difference in scale. Imagine holding a nickel in one hand and a basketball in the other. The contrast is stark and almost unimaginable when you think about it in terms of planets. Now imagine trying to fit as many nickels as possible inside that basketball. It seems like an impossible task, but it gives us a tangible way to understand the vastness of Jupiter. You could fit a lot, right? The sheer number of nickels that would fit inside a basketball is staggering, and this is just a small-scale representation of the actual difference in volume between Earth and Jupiter. Well, Jupiter's volume is so immense that you could fit over 1,300 Earths inside it. This mind-boggling fact highlights just how massive Jupiter truly is. This comparison highlights the mind-boggling difference in volume between the two planets. It's not just a matter of size, but also of capacity and space. Jupiter's diameter is roughly 11 times larger than Earth's. This means that if you could line up 11 Earths side by side, they would barely stretch across Jupiter's equator. If you could line up 11 Earths side by side, they would barely stretch across Jupiter's equator. This gives us a sense of just how wide Jupiter is compared to our own planet. It's a humbling realization that puts our own planet's size into perspective. When we look at the vastness of Jupiter, we begin to understand just how small and fragile our world is in the grand scheme of the universe. This perspective not only humbles us, but also inspires a sense of wonder about the universe. The scale of celestial bodies like Jupiter reminds us of the vastness of space and our place within it. As we continue to explore and learn more about our solar system and beyond, these comparisons help us appreciate the incredible diversity and scale of the cosmos. They drive our curiosity and our desire to understand more about the universe we inhabit. So the next time you look up at the night sky, remember the basketball and the nickel. Think about the immense scale of Jupiter compared to Earth, and let it fill you with awe and curiosity about the wonders that lie beyond our tiny blue planet. Now you might be wondering how we arrived at the figure of over 1,300 Earths fitting inside Jupiter. It's a fascinating question that delves into the realms of astronomy and mathematics. To understand this, we need to explore the concept of volume, which is the amount of three-dimensional space an object occupies. This is not just a simple measurement, but a fundamental property that helps us compare the sizes of different celestial bodies. Imagine you have a measuring cup. Just as you measure the volume of liquid it can hold, we measure the volume of planets. However, instead of using cups, we use mathematical formulas. The formula for the volume of a sphere is 4/3 pi r cubed, where r is the radius of the sphere. This formula allows us to calculate the volume of any spherical object, including planets. To calculate this, we use the formula for the volume of a sphere, which is 4/3 pi r cubed, where r is the radius of the sphere. For Earth, the radius is about 6,371 kilometers. When we plug this number into our formula, we get Earth's volume. But what about Jupiter? Jupiter's radius is about 11 times larger than Earth's, approximately 69,911 kilometers. Jupiter's radius is about 11 times larger than Earth's. This significant difference in size means that when we calculate Jupiter's volume using the same formula, we find a much larger number. Specifically, Jupiter's volume is over 1,300 times greater than Earth's. This is a staggering difference that highlights just how massive Jupiter truly is. When we plug those numbers into the volume formula, we find that Jupiter's volume is over 1,300 times greater than Earth's. This means that if Jupiter were hollow, we could theoretically fit over 1,300 Earths inside it. This is a mind-boggling concept that really puts into perspective the immense scale of Jupiter compared to our home planet. This means that if Jupiter were hollow, we could theoretically fit over 1,300 Earths inside it. However, it's important to note that Jupiter isn't hollow. It's a gas giant primarily composed of hydrogen and helium with no solid surface like Earth. This composition makes Jupiter fundamentally different from the rocky planets in our solar system. Of course, Jupiter isn't hollow. It's a gas giant primarily composed of hydrogen and helium with no solid surface like Earth. This gaseous composition gives Jupiter its distinctive appearance, with swirling bands of clouds and storms, including the famous Great Red Spot, a massive storm larger than Earth itself. It's a gas giant, primarily composed of hydrogen and helium, with no solid surface like Earth. These gases are the building blocks of Jupiter, creating a planet that is vastly different from the terrestrial worlds we are more familiar with. Understanding Jupiter's composition helps us appreciate the diversity of planets in our solar system. But this mathematical exercise serves as a powerful illustration of Jupiter's immense size. It shows us just how small Earth is in comparison to some of the giants in our solar system. This perspective is crucial for understanding the vastness of space and the variety of objects it contains. It's a reminder that our solar system is filled with objects of unimaginable scale, from the tiny moons orbiting distant planets to the massive gas giants like Jupiter. The universe is a place of incredible diversity and wonder. Each object, no matter its size, plays a role in the cosmic dance that makes up our solar system. Section 4. A gaseous behemoth, Jupiter's composition. Unlike Earth, with its rocky surface and molten core, Jupiter is a gas giant. This means that it doesn't have a solid surface. Instead, its atmosphere, composed mainly of hydrogen and helium, gradually transitions into a denser, more fluid interior as you go deeper. Imagine a world without solid ground, where you could theoretically keep falling through layers of gas. That's Jupiter. Its atmosphere is a swirling tapestry of colorful bands and spots, driven by powerful winds and internal heat. These bands and spots are created by differences in temperature and chemical composition within the atmosphere. Jupiter's composition is similar to that of the Sun, primarily hydrogen and helium. This suggests that Jupiter formed early in the solar system's history, capturing a significant amount of the leftover gas and dust that swirled around the newborn Sun. This makes Jupiter a fascinating subject of study for scientists trying to understand the formation of planetary systems. Section 5. Jupiter's turbulent atmosphere, a world of storms. Jupiter's atmosphere is a tempestuous realm, home to storms of unimaginable power and scale. Winds whip through the upper atmosphere at speeds exceeding 300 miles per hour, creating the distinctive bands and swirls that characterize Jupiter's appearance. One of the most striking features of Jupiter's atmosphere is the Great Red Spot, a colossal storm that has been raging for at least 4 centuries. This storm is so large that you could fit 2 Earths inside it side by side. Imagine a storm that has persisted for generations, a testament to the immense energy and forces at play within Jupiter's atmosphere. The Great Red Spot is a high-pressure region in Jupiter's atmosphere where gases are rising and circulating counterclockwise. The exact mechanisms that drive and sustain this colossal storm are still not fully understood, making it a subject of ongoing research and fascination for astronomers.